My name is Garrett Gross. I'm finishing up a Bachelor of Science here at SNHU. Today, I plan on walking you through my capstone portfolio, which I will use for all three enhancements planned for this class. Um, it is intended to be a very simple, rough order optimization app where the user can create orders with addresses and then optimize a route to deliver those orders. So um, I work in logistics, and I thought this might be a good way to merge the two worlds. So I'm going to take you through what I created as the scaffold for this app, and then tell you how I plan to enhance it. Um, when I say scaffold, I mean it is truly a scaffold. We're not doing anything special here. We're initializing the app. We're creating a templating engine. We have a in-memory array to store data, and we're just rendering that HTML. For forms, um, we create these form elements. This is just a simple Python class. It's a data structure I came up with really quick to just help create a form on the screen. So it's nothing very special at all. And we are creating a form data uh, object to pass down to the templating engine to render that form. So, and how that works is there is a form partial that loops through all the elements in the form, and then we do an HTMX post to the URL there. Um, when we create an order, we give it a UUID, and then we add it into the in-memory array. We just add this deal. I put a none data type here at the end for whether it's optimized or not. Print it out to confirm, nothing there. And then here we're just rendering some pages, not doing any logic at the moment. This gets us to how we want to improve this. The biggest thing as far as software design and engineering, there's two major things that we absolutely need to fix as part of this project. The in-memory storage is by far not ideal. I'm literally storing tuples into an array to start. So what we'd like to do is abstract the storage out into an interface and then just put these arrays behind a separate storage object somehow, so that way when we go to implement the database later, we can reuse the same interface and make things really simple to implement. The second major thing is how monolithic the current app in the current state is. What we have is everything happening in main.py. Main.py in my projects personally I like to use for just configuration of the app. Fast API has the ability to do routers, and so what we'd like to do is like create an orders router, create an optimized router, and a routes router that will handle the actual routing of the responses and routing the requests and responses around. Then we would want to put the business logic into some kind of controller architecture or service architecture, so the router can call the service. Ideally, there's a layer of abstraction in between. So those are the enhancements I plan to do as far as software design and engineering. As far as algorithms and database or data structures, is going to all pretty much live inside the optimized service I create. We're going to make an API call out to geocode these addresses, and then we will, as part of a data structure, build out that distance matrix with sign distance, which is like as the bird flies distance. And then the algorithm itself will be the optimization of those distances. So we will perform some two-opt approach where we we connect each point with its closest point, and then we will swap points around randomly until the total distance doesn't get any shorter, and then we will call that optimized. As far as the databases, we'll have to store a few additional fields, but I'm thinking we'll only need one or two tables here for address, city, state, description, and maybe a few other things related to orders. I'm not even sure if we're going to store routes. I don't think so. I think it would be best just to display the optimized route at the end here, and then just keep track of those orders in the database by marking them as complete. So, yeah, I'm really excited to get started, and I hope you enjoy it.